Hello guys, welcome to another video. Today I would like to discuss what is feature store in Databricks. If we go to Databricks and if we click on features, here we can see all the tables which we have created. Right now I don't have any table created, but I'll create and I'll show you. So what exactly is a feature store? Like if I explain in layman terms, assume I work for a wine company and I obviously have some features like the quality, the pH value, and some other acidity values or some kind of information related to wines because I work for a wine company. And so there can be some common features, right, like which can be used across other teams as well. So if you have a scenario like this where you have some common features which can be used by multiple teams, then you can store that information as a table inside the feature store in Databricks. So that table should for sure have a primary key. Without having a primary key, it does not support, because when you have the primary key we can look up. That is the point they have restricted, that we need a primary key to store or to create a table in feature store. So what are the things we have in feature store? Like in feature store we will store the tables, that's it. We'll store the delta tables only, but they should have the primary key mandatorily. Features are nothing but the columns, like each column will have some kind of information. As I explained before, if I work for a wine company, there can be some columns like the pH, acidity, and some these kind of features. So if I have some common features, and if multiple team needs to use that kind of information, then I can create that in a table and store it so that anyone can look up and use it. That's the explanation if you ask me what is the purpose of feature store in Databricks. So to give some detailed explanation, feature store in Databricks is used to store feature tables centralized so that anyone can use those tables during model training. If they need those features for their model training, like if they want to use those features for their model training, they can just look up that table. And also we can update the feature tables whenever we get the fresh data. For suppose if I have some 1,000 rows today, and if I get some more information, I can even update the feature table. I can create a notebook, and in that I can write the update statement. I'll show you how we update the feature tables, and I can run it using the pipeline whenever I get the data, so that the feature table can stay up to date, so that whenever anyone wants to consume, they can consume the most latest information. And how do we consume the feature tables? How do whoever want to consume those features, that data in that table, how do they consume? They can consume using feature look. There is a class called feature lookup, and using that feature lookup we can look up our data with the feature data. There should be some common column between our data and the primary key of that feature table. For suppose if I have wine id, I mean, in the example which I'm going to explain, there will be a column called wine ID. So my data frame will have the wine ID and the feature table will have the wine ID, so that I can join both. I mean, I don't need to do any manual join. It internally joins both and fetches those features into our data frame. And the next is feature function. Like feature function is nothing but the normal Databricks function, which is used to calculate the values dynamically during the inference or during the runtime. If you have something to calculate during inference, then you can go with feature function. I'll explain that as well. And also one main thing, I'll show you this notebook from the Databricks documentation as well. Feature tables also supports time series data. For suppose information like sensors, which will be continuously flowing, so that at one point of time we have to use that point of time data only. We can't use the previous data or some yesterday's data, any kind of old data. We have to use that point of that. The timestamp should also be the primary key. Along with the other primary key, we should have the timestamp as well. I'll show you that as well. So let's go to the example and see how we create a feature table, how we update the feature table, and how do we look up the feature table and get the features. Features I mean by columns here, and use those columns which we have looked up into our model training, in our model, in our data set. So right now I don't have any features, and if I go to my catalog, I'll use this particular schema. Inside this catalog I have WineDB. I use this particular schema for everything, for creating a feature table or for models and everything. So I'll go to workspace. I have this notebook, and in the my cluster is started. So I am just importing all those libraries whatever I need. And then if you see here, my first task is to get some sample data and create a feature table. If you see here, I'm reading some sample data from Databricks datasets, and I'm creating a primary key column. It's nothing but an incremental number to each row, because my feature table needs the primary key. Without that, it does not accept. And I'm selecting only the required columns. And like the purpose of selecting this is that I'm assuming these four columns are the common features which can be used by anyone or any team. So I've just selected these four columns alone from the dataset which I have read, and I've removed the spaces. That's it, just to rename, or by removing the spaces in my header I have the spaces, so I'm just removing those spaces. And I'm dropping the target column. I mean, this is the label column for my model. I'm dropping those. That's it. Just reading some sample data set and assuming that these are the four common features. That's it. And I using those features and that primary key, I create a feature table. That's it. And I'm just using so and so database. I'm just asking my notebook to use so and so schema and database. So this is the data, guys, which I want to use. This is a wine ID, which is a primary key, and these I'm assuming these four are the common features which can be used by any model whoever wants in my organization or a team. So I'm just creating a feature table out of this. I'm just using that, and using the object which we have created based out of this class. When we call fe.create table, it creates the table, and the arguments we need to pass is what is the name of the table should be, what are the primary keys, and what is the data frame with which you want to create a table. This is the data frame, and this is the schema, and I'm just small description. So the above data frame which I have created, features df, and I'm passing here, and I'm creating a feature table. That's it. So once this is executed, if you see here, guys, it is clearly setting up wine ID as a primary key to a not null column, and wine ID is a primary key, and okay, it is creating a feature table. See, it is doing all the purpose what it has to be done. And if I come to the features, there is nothing here, and if I refresh, I should see that table which should be created right now 32 seconds ago. And this is the table which we are creating as a feature table. So anyone in our organization wants to use the features in this table, features I mean by columns in this table, they can directly call the feature lookup method, and they can use that. That feature lookup method will literally does the join. We'll see that as well. So that's how we create a feature table. And if you want to update the feature table, the data frame name, the name of the feature, and mode merge. If you see, it updates based on the primary key. If you have any change in any column for a specific primary key, it does the merge. If you write overwrite, it overwrites everything. So this is how, if you keep these two commands in a notebook and schedule the pipeline and run it periodically, our feature table gets updated every particular interval. So that feature table will stay up to date. And this is just for example. If you want to read a feature table, you can just do fe.read table of that feature table name. That's it. So it will have all the data whatever we want. That's it. See, it has this data, the primary key and the three feature columns. So that's it. That's how we create a feature table. That's okay. Now I'm just creating a function here. The purpose of this function is to just calculate the average of the columns we have passed. So I mean, the purpose why I have created a function is to show you that we can dynamically calculate something before training a model using Databricks functions. If you have anything to calculate dynamically, then you can use Databricks functions and pass the arguments we want, and it just does the operation we want. It does execute the logic we want to have. Here I'm just calculating the average. So I just created a basic function just to show you how we can use feature function and feature lookups in Databricks features. Okay, so this is my real data. The data which I have created above is to just create a feature table. Okay, now this is the real data I am using from my volume path, and I want to train my model with this data. Along with this data, I want to use the features which are there in so and so feature table which I have created above. Along with the columns which I have, I want to use those columns also. Okay. So I just read the data. As I don't have any primary key, I'm just using binary. I'm creating a new column. That's it. I'm just removing the spaces and all similar to, and I'm dropping those three columns because the data which I am feeding into feature table and the data which I am reading here are exactly same. The intention of this video is to show you how to create a feature table and how do we look up those columns. The underneath data is same, so I'm just dropping those columns because these three columns I want to get from feature table instead of directly reading from this. That's it. So if I run it, I will have this final data frame, and it will have all the wine ID as a primary key, and these are the columns, extra columns, and I want three extra columns which I look up from the feature table. If you see, I'm just casting some columns to float here. That's it, nothing else is done. And this is the part, this is the major part which is related to our topic today. Okay, so here I am creating an array inside which I have two elements. One is feature lookup, one is feature function. Okay, the sole purpose is I need to create a data set with the data which I have read, and also I need to look up from the feature table. So the FE which we have created, the object.create training set, will create the data using the data which we have read, the final data frame, and here we are calling the list which we have created above. So what does this list do? First is feature lookup and is feature function. Let's see what does feature lookup does. In the feature lookup, we are just passing the table name. This is the name of our feature table. This one, wine features. That's it. And what are the features we want to read from that table? This table has some columns, right? So we just are looking for so and so, these three columns only. If you want to two columns, you can just select two. I need all three, so I just selected those three columns. And if I want to rename the columns, you can just rename using this particular dictionary, rename output. If I want the sulfates column to have some other name after reading, you can do rename. So this is the lookup key. What is lookup key? Wine ID. So what happens is, with the data frame we read here as the wine ID, right? This one and the feature table joins based on the wine ID and fetches these three columns and appends it to our data frame. So our training data set will have what are the columns which are present in this final data frame, as well as the columns which we are fetching from our feature table. That's it. That's what this does. This is just doing a lookup. Instead of manually joining, they have created a class called feature lookup, and we need to use that class by passing the required arguments, and it does the lookup internally. That's the purpose of feature lookup. And what is the feature function? Here we are calling a Databricks function, and in this Databricks function we are passing an arguments, and it will do the average. Like, I am doing the basic operation here, but we can do much complex things in the real world. So the output of the function should have the column name called acidity average. That's it. This is what I want as output. So in the input, I am just passing the column names here. What is the column name which I am passing, and to what it should map to? If we come and see this method here, I didn't execute this method. If I execute this here, I just want the fixed acidity to map to fixed acidity, volatile acidity to map to volatile acidity, and citric acid to citric acid. If I have some other column names, and if I want to map, we can do that as well. Just to map the column names of our data frame with the so and so argument in the function, we need this input binding argument. That's it. So we are just saying there is a label called quality, which is my label in our source data set. I mean, in this final DF. That's it. So when this particular, also there is one more argument, exclude column. If you don't want any columns to have in your training data set, you can mention them here. I don't want the primary key to be there, and I don't want this ID column to be there in my training data set. So I just mentioned. So what it does is, it internally does whatever is mentioned in this loop. One is lookup and another is calculating the average based on the 3 columns. That's it. And it returns the output. And we are just loading that into a Python df. That's it. And we are doing train test split. So I'll just execute this. And if I show you the data, you will get more clarity. So that's it, guys. So these are all the source columns, and from sulfates to density is the lookup columns, and this is the column which got created based on the function. See, acidity average. That's it. So these are the two things which are supported in the feature store. One is lookup and another is feature function. So with this, we can easily and dynamically generate the data set. This is a very common scenario in every organization where so and so team holds some kind of data, and that data can be looked up by many other teams. That's how the data warehouse and everything is built. So to handle that kind of scenarios, we can use Databricks features and create a table in Databricks features, and anyone can easily look up and train these models. And the next part is ML flow, guys. I have made a previous video very clearly on what is ML flow, and here we are just initializing the ML flow. That's it. And we are just naming this is our model, and the model should be in a WineDB only. We are naming our model name as Wine model, and we are initializing the ML flow. That's it. And inside ML flow dot start run, we create our algorithm we want to use, and we fit the and predict everything inside that, so that everything can be logged in using ML flow under experiments. We'll show that as well. Right now, if I come here, these are the 1 hour ago previous runs. Okay, so when I run that, everything gets logged in my ML flow. ML flow is a framework which is open source and by Databricks, which is used to maintain the life cycle of the models, like from training, what are the features being used, what are the metrics being calculated. Complete model training life cycle can be maintained using ML flow. That's it. So I'll just run it, and we should see another run over there. If you see, this part is not related to ML flow. This part is related to a feature store only, because we are using that object and log model. It has run successfully, and we should be able to see there. If you see here, see ML flow has tracked everything here. This is the run ID, and these are the metrics we have calculated. So these metrics values are stored here. It's a very bad model because the data is not proper. Any parameters being passed, and this comes into ML flow. And if you want more details about ML flow, you can watch my previous video. So this particular piece of code is not related to ML flow. This is related to feature store only. Here we are just calling a feature.log model, inside which we are passing the model name, random forest regressor, and the artifact path where we want our feature metastore information to be stored, and what kind of model we are using. We are using sklearn model, so we have to use mlflow.sklearn. What is the training set we have used? The training set which we have created here, this one, and the model name which we have given here, this one. So what it does is, the whole purpose of this is to log what are the features being used while training this model. That's it. That's the whole intention of this, so that it can be tracked as a lineage. Okay, I'll show you that. And that's it. Next is, we have another method called feature score batch. When you call this method, it's kind of batch prediction method. It uses the model which we have created above based on the model name and the latest version. Latest version will be 1. So this fe.score batch method is used to predict the values for the data frame which we pass here. That's it. We are passing final df here, and for each and every row, what is the predicted value that can be printed here. That's it. and if you see for this data, we'll get a new column called prediction, and what is the value it has predicted. That's it. That is what we get here. That's it. And if you see, the actual label is 5 and it is predicting 5 5 5 5, something wrong as well, but the intention is to show you the feature store, not on ML. That's it. We can even print that data frame which we have printed above.